Hi viewers, here we have our ES55 series of zero differential solenoid valves. They're a 304 stainless steel body. Great for applications such as tank drain, low pressure, vacuum, things like that. Things where you don't have a lot of differential pressure across the valve. Now, things to note is the direction of flow is moulded on the lip of the valve. That's the first thing you've got to do when you install it, is get the direction of flow correct, otherwise it won't work properly. 304 stainless steel body, IP65 weatherproof dim plug connection. Now if I just take it apart to show you how it works, to nip the coil off, just undo the top bolt. And here we have the valve without a coil. It's got the operator stem here and the body of the valve. It might be easier now to see this arrow which is moulded on the lip of the valve. That's the direction of flow arrow. Now if I take the top off the valve, as I take this off, you'll see why we call it a coupled diaphragm. I've just slipped the top off, and here we're really left with the lid of the valve and the operator stem with nothing in it. On here you can see the armature, the spring in the top. This is a normally closed valve, so it keeps sitting on the seat, is attached to the diaphragm. You might be able to see side on. So they call it a coupled diaphragm. Well, imagine this is the coil's powered up and the armature's pulled up. You can see it lifts the diaphragm out. So when there's no pressure to help open this, the armature will pull the diaphragm up slightly. This will allow flow through at very low pressures, or even when there's nothing present, it will still open. Now, it is still pressure assisted, so the pressure will help it in the line. Now, how does it help it? Well, into this diaphragm here, you will see this hole here. This is the bleed on hole. So inlet pressure comes up and comes onto the top of your diaphragm. Now, the pressure can't escape when it's closed because this armature is sitting down on the jet where it's coupled. However, when it's pulled open, like so, the pressure can escape off. Now, the bleed hole off is bigger than the bleed hole on. So in here, got the flow going through, it'll push the diaphragm to the roof of the cavity and your flow will go through. Now this is an NBR diaphragm, so it's pretty good all round. We don't really use them with hydrocarbons such as diesel and fuel because we feel Viton's better. But it's good to about water to about 80 degrees, or medium up to 80 degrees. A good all round diaphragm. Under here you can see the machined seat, nice face. So you've got flow here, up and around, and then flow path down and through. If you're putting it back together, make sure you put the spring into the top of the diaphragm, into the top of the armature, and make sure this body O-ring here sits around in this seat here before your diaphragm goes on. Now the diaphragm forms part of the gasket of this valve, so it helps it seal. You can see it's clamped in place. Slide the top back on. And then put your bolts back in.